let's solve some logarithmic and exponential equations. And basically, if you can convert from one to the other, then you're good. So let's take a look at the hints. There they are, right there on your paper. See them? See them? Yeah. Basically, these are the two biggest hints I can give you. If it starts in logarithmic form, go to exponential form. If it starts in exponential, go to logarithmic. That may not make much sense right now, but in just a minute it will. So let's actually look at number 1, and it's on your paper, clearly. And we're going to use our calculator some. Now, for number 1, we don't need to. You probably know what the answer is. Now, if you said the answer was 10, then you are wrong because it's not 10 times what, it's 10 to what power. So be careful with that one. But I'm going to pretend like we don't know that the answer is 2 because 10 squared is 100. And we're going to rewrite it so I can kind of get you in the flow of doing these because not all of them are going to be nearly as intuitive as this one. So right now this thing is in exponential form, and because it's in exponential form, there is a variable hanging around in the exponent. We need to switch it to logarithmic form. We're going to use this inverse operation here. So log of 100, there's an understood 10, we don't have to put it, is equal to x. Again, we know the answer is 2, I know it's 2, you know it's 2. You can just type this straight in your calculator and it will tell you the answer is 2. Not all of them are going to be that clear. We're going to come across several, most of them, that have crazy decimals as answers. We're going to round to 2 decimal places, so the nearest hundredth. Okay, here's number 2. 2 to something minus 1 equals 16. Now, we can do this in our head, and actually I'm going to guide you through the process in your head, but this is the last one we'll be able to do in our head, unless you're a complete math genius that can do tons of stuff in your head. I'm not one of those myself. I can't do things in my head that are that crazy. But I can do this one. 2 to what power gives me 16? How many 2's would I need to multiply together to give me 16? I think I just showed you the answer by accident. 2 times 2 is 4, times 2 is 8, times 2 is 16. So we have 4 2's. So this exponent better equal 4. So in my head I say something minus 1 equals 4. And the answer is going to be 5. Now, not all of them are that intuitive, and that might not have made sense. Maybe it did, maybe it didn't. I don't know. But we're going to rewrite it using the hints up at the top. This is exponential form from the very beginning, so we're going to write it as a log. Log base 2 of 16 is equal to n minus 1. And we're going to solve that. Now, you've done this. You know what you're doing. So what we need to do is figure out what this is, and it is 4. But in case you forgot, let's get you back on the clue bus here. Log of 16 divided by log of 2. There we go. Boom. The answer is 4. So 4 equals n minus 1. That's fantastic. We're solving it. I know how to solve this. You'll add 1 to both sides, and you end up with n equals 5. There we go. Now, the next one is not going to be nearly as clear. And no, the answer is not 6. It's not 3 times what, it's 3 to what power. The answer is actually going to be 2 point something. Ask me how I know, ask me how I know. How do I know? Okay, thanks for asking. Because 3 squared is 9, and 3 cubed is 27. So 2 is too small, and 3 is too big. So if my exponent was a 2, it'd be a 9. If my exponent was a 3, it'd be a 27. And so because it's between 9 and 27, the answer is between 2 and 3. Just throwing that out there. Okay, we're going to write it as a log, base 3 of 18, and that is equal to x. And we're going to type that in the calculator, just like we've been doing. Here's what you type. I'm not going to walk over there and show you, but you got this. Log of 18, parentheses, divided by a log of 3. Big number, font-wise, divided by a little number. Often that is a smaller number, but log of big font number divided by a log of base. So we end up with a number that's 2 point something, and I don't know what it is. You might have beat me to it. I hope you did. There we go, 2.63. 2.63. Now, by the way, if you want to check your answer, you're going to be off a little bit because you rounded. So am I. So if we did in our calculator 3 to the 2.63, we're going to get something really close to 18, but not exactly right. But, you know, that's to be expected because we rounded. So we had 2 to the, I'm just checking, 3 to the 2.63. And yeah, I got 17.98. 2 pennies off. There we go, 17.98. Close enough. Okay, again, exponential form, exponential form, exponential form, and based on the 2 hints you see up at the top, it says if it's in exponential form, convert it to a log. So we're going to convert this into a logarithm. So we have the log base 6 of 11 equals 2n minus 3. Log base 6 of 11, 2n minus 3. Before we go any further, we need to figure out what this is. So we grab our calculator and we type this in using the change of base formula that you just learned recently. So log of 11 divided by the log of 6. That's the way calculators do it. We get 1.34 when we round to two decimal places. 2n minus 3. You know how to solve this equation. If you don't know how to solve this equation, then we have bigger problems than logarithms. We're going to add 3 to both sides. That gives me 434. That's equal to 2n. We will divide both sides by 2 in order to eliminate that 2 right there, and we get 2.17. We are finished with that problem because n is by itself. We know what n is, and we are done. Let's move on to number 5. Is number 5 in logarithmic form? Now, a minute ago I said it was, and I halfway lied to you. Nothing personal, sorry. It actually is not in exponential form. It's not in exponential form yet, nor is this one. That 3 needs to move. So before we can start writing it as a logarithm, we need to get this constant to the other side. So we'll subtract the 3 from both sides. 5 to the n minus 2 equals 6. Yeah, if you're ahead of me, then you'll realize that this one's going to equal 16. Okay? That's not the final answer on that one. But we subtract 3 from both sides, and now we're ready to write it as a log. Log base 5 of 6 equals n minus 2. And we will find out what that is in our calculators. Log of 6 divided by the log of 5. And we have 1.11. 1.11 equals n minus 2. And now we need to add 2 to both sides to solve it. So we'll add 2. And we get 311. 3.11, which is a highway. It's also a band. Okay. You good? Before we tackle number 6, any questions? If you do have questions, I can't answer them, obviously, right now. But rewind it. Catch something else if you need to catch it. Pause it and catch up if you need to. But let me restate something that's very important. If it starts as an exponent, you turn it to a log. If it starts as a log, which we'll get to in a minute, you turn it into an exponent. You do the opposite of what it is. This one started almost as an exponential form. That 1 is in the way, so now we really write it as 8 to the 2n equals 16. And a lot of people look at that and they say, oh, 8 times 2 is 16. Yeah, sure it is, but that's not what we're dealing with. We're dealing with an exponent, not just straight up multiplication. So we're going to have to write it as a log. Log base 8 of 16 equals 2n. Okay? Find out what log base 8 of 16 is. I'll go ahead and tell you. It is 4/3, I believe. You're going to get 1.3 repeating, if I'm not mistaken. 1.3 repeating. Can I tell you how I know that? We need to turn an 8 into a 16, so we're going to take the cube root, turn it into a 2. Cube root has a denominator of 3, if it's an exponent. So I know it's going to be something over 3. We just turned it into a 2. 2 to the 4th power is 16. There we go. You have 1.333 if you got it in your calculator. We're going to divide that by 2, and we actually get 2/3. You have 0.666666666. It rounds it off at the end of 7. I'm fine with that. Prefer 2/3. It's a little more accurate. Okay, I'm trying to squeeze all this into one video. We're going to go ahead and jump straight to number 7. You may need to simplify some of these first, but not quite yet. So let's go ahead and start erasing while I talk about what's about to happen. They're going to start as logarithms, and then we're going to have to convert them into exponents. It's almost always going to be the opposite of where you start. Sometimes you're going to need to do some crazy things like combine some logarithms or simplify some things, move some coefficients and exponents around, things like that. All right, here goes number 7. Log base 2 of x equals 7. Let me ask a stupid question that I've already asked, or I've already said the answer to. And I will point to the answer. What form is that in? It is in logarithmic form, and because it's in logarithmic form, we're going to convert it to exponential form. So here we go. We are going to do this little thing right here. You saw it in the other video. The base to that power equals that number, or that variable in this case. The order in which you point to them is the order in which you write them. This is how we go from logarithmic to exponential form. 2 to the 7th power equals x. And now it's just as simple as finding out what 2 to the 7th power is. It's 128, by the way. Please don't grab your calculator on that. Don't. Come on, you got this. Let's just keep doubling stuff real quick. Let me show you. 2, 4, don't say 6. 2, 4, we're doubling. 8, 16, 32, 64, 128. There you go. That was it. Okay. Number 8. Log. Oh, I spelled lag. Apparently I couldn't spell a 3-letter word like log. Lag of 3. X minus 2 equals 3. Okay, so what are we going to do? Well, don't let the fact that this is a binomial throw you off. It's all in parentheses. It's all being logged right now. And so it starts in logarithmic form. And what we need to do is convert it into exponential form. 3 to the 3rd equals that right there. And we'll just go ahead and write that out. The order in which you point to them is the order you write them. When you draw your little heart, or whatever you think it looks like, I think it looks kind of like an oven mitt. But whenever you draw your little heart on there, you may want to say it in your head. 3 to the 3rd power equals that. 2 to the 7th power equals that. 3 to the 3rd power equals all that mess in parentheses. Well, 3 to the 3rd power, don't touch your calculator. You got this. This isn't a crazy thing. 3 times 3 is 9. Times 3 again is 27. 27 equals x minus 2. Don't grab your calculator on this one. If you just touched your calculator, I want you to smack your own hand. All around the room, people are going right now. 29. You had to both sides. Okay, there's number 8. Here goes number 9. And well, it's not going. It's not going anywhere. It's going to stay right where it is. But here it goes. Watch it. There it goes. 2x minus 3 equals 3. Here we go. Here it is. All right. Whoa, that's in logarithmic form, isn't it? Isn't it? Yes, of course it is. And so we're going to write it as an exponent, or write it in exponential form. And when we write it in exponential form, what we need to do is grab a marker and point to that number. What number is that? It's an understood 10, in case you forgot. That is an understood 10. It is not written as a log, it's an understood 10. Later on we'll get to stuff that's not a 10. It's fun, we'll deal with it later. 10 to the 3rd power equals all that mess in parentheses. And write it out exactly like you said. 10 to the 3rd power equals all that mess, no, I'm kidding, equals all that mess in parentheses. Find out what 10 to the 3rd is. Don't touch your calculator. You can use your calculator if you need to, but you don't need it for this. Let's be real. What's 10 times 10? It's 100. Times 10 again is 1,000. It's a G. 2x minus 3. And now we'll add 3 to both sides. We get 1,003 equals 2x. And then we will divide it by 2. Please don't touch your calculator. I don't know why all of a sudden I'm against you using your calculator, but really this math is basic. It looks ridiculous, but the math within it is so basic. Later it won't be. But like number 1 through 6, you couldn't do without your calculator, or particularly 3 through 6. But we're going to divide 1,003 by 2. That gives you 501 and a half. 501.5. There's number 9. Okay, we are going to do 9, 10, oh, we've already done 9. We're going to do 10, 11, and 12, and then we're not going to do those last 3 unless I find it necessary to come back later and hit those. So we're just going to do 10, 11, 12. Don't mark out 13, 14, 15, just in case we choose to do them at some point if we need the extra practice. But for now, it's just going to be 10, 11, and 12, okay? So here go 10. Here goes 10. We have log base 2 of x plus log base 2 of 4 equals 5. Log base 2 of x plus log base 2 of 4 equals 5. Is this in logarithmic form? Your answer might be yes, and you're sort of right. But it's not completely in logarithmic form because it's not one logarithm. It's actually 2 logarithms, and we need to combine them. And we've dealt with this a little bit in some of the other notes. May not have practiced it enough and as much as we should have, but basically when you are adding logarithms, you can combine them together if they have the same base, and they do. You can combine them together using multiplication. I hope that's what you were thinking. So what we're going to do is combine these together and say we have log base 2 of something equals 5. What is that something? Well, it's x times 4. X times 4 is, well, it's x times 4. It's 4x. And now it looks like the other problems we were doing where you have one logarithm and you draw a heart on your paper and you say it in your head, you write it in exponential form, and then you move on. So let's do it. 2 to the 5th power equals 4x. 2 to the 5th power equals 4x. 2 to the 5th power is 2, 4, don't say 6. 2, 4, 8, 16, 32 equals 4x. We'll divide that by 4. Touch your calculator. There we go. 8. Here goes number 11. You got that? Y'all good before I move on to number 11? Any questions? If you have a question, rewind the video, like I said. Also, again, let me just say this one more time. Whenever you're adding logarithms, you need to combine them, if they have the same base, and they do, with multiplication. And if you look at number 11, you'll realize you're subtracting logarithms, which means you can simplify by using division. We're going to do that. If you're ahead of me, be careful. There's a 2 in the front that we're going to have to take care of. So we have 2 log x minus log 4 equals 2. Here we go. What are we going to do? Well, you might have said, well, we should divide. And I don't disagree with you at all. But let's not put the cart before the horse. That's an old medieval saying. Or back when they used carts and horses a lot more than they do now. But let's not put the cart before the horse because that won't work. The horse needs to pull the cart. What I really mean is this. Let's just kind of clarify that metaphor, shall we? You can't subtract these yet. I lied. You can't divide these yet. You need to move that 2 first. That 2 is keeping you from doing what you need to do. That coefficient is making you angry, and coefficients with logarithms become exponents based on the properties of exponents. That's one of the reasons you can do that. So log of x squared minus log of 4 equals 2. And now we can say, well, you know, I'm subtracting logs. They have the same base. They're both an understood 10. That's not going to change. So we'll have log base 10, understood, of divided. X squared over 4 equals 2. And now it looks like all the other problems we've been doing. It does. So in this case, all we have to do is just say, well, there's a little 10 right here. And say it in your head, 10 to the 2nd equals all that mess right there. And you just write all that mess right there. 10 to the 2nd equals x squared over 4. And we're going to solve it. By the way, you could square root both sides at this point. I'm not going to go there, but you could. 10 squared is 100 equals x squared over 4. We need to get rid of that 4. We will multiply by 4. That gives us 400. And that is equal to x squared. And then we erase this little line so we'll have a little bit more room. If only you could do that on your paper. This one doesn't have the lines. Good. We will square root both sides. X equals... Trick question, actually. What does x equal? You're probably about to say 20, and you are right. And that's what I'm going to put, and that is the answer. However, I want to just throw one little thing out there. When you square root a number in the process of solving, often, in most cases, it's going to be positive or negative. So don't write what I'm about to put. You would say, oh, it's plus or minus 20, but you cannot take the log of a negative number and it remain a real answer. It becomes a complex answer, and all kinds of crazy math breaks loose. So if this was negative 20, then this would not have worked. So we're going to toss out the negative. Why did I even tell you that? Because it was cool. Because I want you to get in the habit of thinking, when I square root, it could be positive or it could be negative. Square root of 400 is 20, or it's negative 20, because negative 20 times negative 20 is 400. Nevertheless, negative 20 wouldn't work here. All right, let's do one more, and then I will let you work on the sheet that goes along with it. Number 12 actually is much easier than the rest of them, but it's got a slight catch to it, and it's not so much of a catch as it is an alternate method, and I want to show you the alternate method, so I'm going to write it twice and do it twice. Don't worry, it won't take long. Okay, you have two options, and here's option number 1. Oh my gosh, I have an exponent. That means I will, or coefficient, which means I'll have an exponent. So we have log base 2 of x squared equals 10. And then we say, well, 2 to the 10th power, 2 to the 10th power equals x squared. What's 2 to the 10th power? Good grief. 2 to the 10th power is enormous. Here goes again. 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024. 1024 equals x squared. And we got to find the square root of 1024. Oh, wow. What is that? By the way, it's 32. There we go. So we would have to take the square root of both sides. Now we can do plus and minus, but that takes us back to where we were a second ago. So we just square rooted both sides, just like we did here. And we get 32. Well, Mr. Reader, that's great, but the numbers got really big, really fast, and got kind of crazy. Agreed. Sometimes they get even bigger in situations like this, so let's do this one a different way. We can actually divide by that too before we even start. And we can do it here, but not here, because this one, if we divided by 2, I'm fine. Eliminate that 2. Eliminate that. Divide 2 by 2, you get a 1 over here. But when you divide this by 2, well, he doesn't get touched. And you end up with a 1/2 in the front. And although it could work in this one, in a lot of other cases, it's going to get crazy, and it's not worth the trouble. Let me recap. Get it? Let me recap what I just said. In this situation, you can divide by 2 before you even begin, because you only have one logarithm that you're dealing with. Wow, that was easy. In this situation, it is not going to be very conducive for you to divide by 2, because it creates unnecessary work. Your best bet in this situation is to move your 2 up and let it become an exponent. If you have more than one log, turn your coefficients into exponents. If you just have one log, it might work to your advantage to divide by that coefficient. Log base 2 of x equals 5, and then 2 to the 5th equals x, 2 to the 5th equals x, and sure enough, 32 is x. Like I said, we're not going to do those bottom 3, and I will let you work on the work that follows this video.